Right, hello. Here we go with another one. And this one is going to be circle geometry. Circle geometry. Something happens when you put shapes inside circles. So let's have a look at the first one. And there are some things to remember. Of course, there's a circle, and we draw a line that is a tangent, and we go from the center of the circle to where we meet the tangent, and this is always a right angle. And so we have the little rule that the angle between the radius and the tangent is always 90 degrees. There you go. So that's the first one. Anywhere else in the circle apart from a radius is not guaranteed. Yeah, it has to be right in the middle. Okay, so you'll need to know this because sometimes you're asked for proof. Why is the angle 90 degrees? It's because it's between the radius and the tangent. So you need the proof sometimes. Okay, so let's draw another one now, and we'll come up with another rule. There's plenty of them to have a go at. Yeah, so here's another one. Now we're going to do these freehand. Yeah, so if I do that and that, and this becomes an angle here. So this is an angle subtended, funny word this, subtended from an arc. That's an arc. And if we draw another one there and another one down here, these two angles are subtended from the same arc. So angles subtended from the same arc are equal. Yeah. So if this was 40, this would be 40 as well. Now it just so happens that we have, if I can do another colour, we have an arc here, and we can turn it upside down, and the angles there subtended from the green arc are also the same. It could be anything, but yeah, it doesn't matter where it is. If they come from the same arc, they are the same as each other. Right, so let's see what the next one is that we can do. So we can do a couple of little examples here. We just do two of each to get the hang of what we're doing. Oop. Oh, look at that. We've got two. No, I've got one there. Now let's do another one there. Okay, so we got two triangles there. Circles even. I wonder if can't move it. Can't move it. Won't work. So we go back to where we are. And so let's do two quite complicated ones, yeah? So we're going to have that and that, and ooh, that. Imagine that's in the middle, and we'll come down the outside. So absolutely perfect. Yeah, and then we're going to have one there, up there, down there, and back across. So the first one, we're given 80 degrees, and we've got to find this one up here, and this one will be, say, 30 degrees, and I wonder what that is. That is y. Right, so angles subtended from the same arc are equal. Therefore, x and y are both the same because they're coming from this arc over here on the left. Now, what can we find out about this? We can work this angle here, the 80, and this one here are both on a straight line. So we can find that unknown one there, which is 180 minus 80, which equals 100. Yeah, so we've got 100 there, and we've got 30 there. So 180 angles in a triangle. Take away the 130 we know about, and it equals 50. So y equals 50, and x also equals 50 because they are subtended from the same arc. Now, this one, so we'll call that 50. Oh, hang on, what do we do? Let's call that 50. And let's find what x is. Can we do that with enough information? Now, if we call that 50 as well, then we know that these two are the same because they are subtended from this arc here. Therefore, x equals 50. And what else can we find on here with this one? Now, we could find all of that, couldn't we? Yeah? Because 50 and 50 from 180 minus 100 will be 80 degrees. So all of that is 80. All of that is 80. Not necessarily split down the middle, but however, if that's 50, yeah, that's about all you can find from there. It doesn't give anything else, no, so it's just find x. I was just looking around to see whether we can find something else, but we can't, so we're not going to. So what we got now? Okay, let's do another little rule, which is this one. And if we have the center there, and we draw a line there, and we go from the same arc up here, this one and this one are subtended from the same arc, which is down there. So this will be the rule for this one is going to be that the angle at the center is equal. No, it's not equal. It's twice the angle at the circumference. Yeah, twice the angle at the circumference. Right, so let's have a couple of examples of this one. We will draw a circle and another circle as well. So we've got two examples of the same thing. Right, so this one, we can have this, and there's the center. And we'll go up to there, down to there, and across. Right, so this first one, we're going to be given that is 14, and we have to find this one. Now, when you have a triangle that is made up of from the center, that these two are the same because they're radiuses, that makes these a nice isosceles triangle. So this is 14 as well. So we've got 28 together, and we take it away from 180. And let's see, so it's 2, 5, 1. So this one is 152, and therefore x is half the size of 152. So if we do 152 divided by 2, that gives us 76 degrees. Good. Now let's do one here. And be careful that things that look like right angles are not necessarily right angles. So this is going to go through the middle there. And we need to find x. And we're given that this one is, let's make it 60, make life easier, yeah? So this is a equilateral triangle. Therefore this is 60. In fact, it's an equilateral, yeah, not an isosceles, but yeah. And this is 60. Now we have a straight line here. And if that's 60, we do 180 minus 60 equals 120. So this is 120. And we have an isosceles triangle up here. So 180 minus 120 equals 60. So these two, this one and this one, share the 60 degrees equally between them. Therefore x is 60 divided by 2, which is 30, equals x. Okay. Now, we'll have another, this time we'll have a four-sided shape inside the triangle. So, right, so the rule here is if we have a four-sided shape, no matter what it looks like, yeah, the opposites add to 180, yeah? And so these two add to 180 and these two also add to 180. So in a four-sided shape, a quadrilateral, a cyclic quadrilateral, because it's inside a circle, opposite angles add to 180 degrees. So see whether we can do an example of this. How to find an example of this. So I've got one there, and we'll do another one down there. So the opposites add to 180. So let's do this, and this, this, and this. There's a four-sided shape with that one, and there, there. Okay, right, this first one here. Let's have a look. So we've got some, call that one 100, and call this one 110, and let's find angle X in there, that bottom left hand corner, and let's find angle Y over here. Okay, right, first up, this is a straight line, therefore this one will be 180 minus 100, so that makes 80. And opposite angles add to 180, so this means x will be equal to 100. And opposite angles here add to 180, so this will mean that this angle over here is 70, and y and the 70 are on a straight line, therefore y will be 180 minus 70, which is 110. Right, we've got 40 degrees here, 40 degrees, and we want to find out this one, x. Okay, now we need some extra information. This is a isosceles triangle, and this is an isosceles triangle as well. So this one equals 40, yeah? Now this one is going to be 180 minus 80, so therefore this one is 100. And here's the opposite, so they add to 180, so therefore this is 80. Isosceles triangle number 2, this is 80, so that's 160, so this makes this one 20. So all on a straight line, 180 minus 60 is 120 equals x. Yeah, good. Right, so we got these. Now, next one up, next rule is this. If we have a diameter and we make an angle at the circumference from the diameter, it is always 90 degrees. It doesn't matter where it goes. Where it goes, it's always 90. So an angle subtended from the diameter is always 90 degrees. Okay, good stuff. So let's have a couple of examples of this. When this bombs into shape, there's one. There is two. Right, on this one, what can we do? What can we do? What can we do? Quite complicated shapes this. So here's a straight line that goes through the middle, and at the top we've got an angle there, and then we've got this weird thing. So this is not straight, so that goes there, and we'll put a line that goes across there. Right, so we need some angles down here. So we call this tiny one here 20, yeah, and we'll have to find this one, x, over there. Right, so anything comes from the center, it's an isosceles, at least, triangle. Therefore, this one will be 20, and they two make 40. They two make 40, and if that is 40, so 180 minus 40 equals 140. So that one is 140. Now, this is on a straight line here, so this will be 180 minus 140, which is 40. So now we've got that, and we've got, what else have we got? Do we need another information? Yeah, if that is a straight line, the diameter, this whole angle here is 90. Now we know 20 of it, so 90 minus 20 equals 70. So this bit here is 70. So we've got 40 and 70 make 110. 180 minus 110 means this one is 70. Also, because we've got from a radius there and a radius there, so that makes that an isosceles triangle as well. So these two are definitely 70. So let's have a look at this one. There. Whoop. There. What else can we do? That's that one. So another one there. Now, are we given anything? Let's say that that is 40, and let's say that that is 20. Can we find x, y, and z? Right. First up, this is an angle subtended from the diameter, so that's 90. 90 and 40 is 130. Therefore, this is 180 minus 130, which equals 50. So x equals 50. Here's another right angle there. How does that help us? Oh, we've got a vertically opposite, so that's 40. Yeah, these two. So 40 and 90 make 130 again. Therefore, this z is also equal to 50. Yeah, 180 minus 130 is 50. So that's 50. Now, what have we got? We've got 90. Oh, we found x, didn't we? It's 50. So 50 and 70, 50 and 20 make 70. So that's 70. This is 90. Together they make 160. So this big triangle is 180 minus 160 equals 20. Yeah, so y equals 120. Right, now the next one, there's only two more to go with this, so not too bad at all. It's quite a high level subject, this one. So what we've got is this one. We've got, let's draw a tangent. Let's draw a tangent. And let's draw a triangle in the point of the triangle goes down to there. And we'll call this angle here 80. Okay. So this angle is, this is the alternate segment, and it means that this angle is the same as this one, so this will be 80 as well. Now if this is 70, it will mean that this is 70 as well. Now this one, x, if all add up to 180 in a triangle, and we've got 70 and 80 so far, so that's 150. So we would do 180 minus 150. Oh, yeah, it's equal to 30. So that one will be 30. Now we could do this the other way with a straight line. These add up to 180 as well. 80, 70, and x. So there's another 150. Take away from 180, and that would mean that that is also 30 degrees. So that is the alternate segment. And the last one is to do with tangents. Tangents from the same point are equal in length. Right, so we're going to do the center, and we'll do one there, a radius, and we'll do one there, a radius, and we'll do a tangent. I'm going to have to draw it in two parts to keep it straight. Okay, let's just extend that and extend that one. So we know that a tangent to the radius causes a 90-degree angle, and these are originating from the same point, so that, get rid of those little bits at the end. So that means that from here to here and here to here, they are the same length. Okay, that is your lesson on circle geometry.